Welcome to Science's Curiosity. Here we carry you through amazing scientific discoveries of our time. Click subscribe to stay closer with us. I can't wait to travel on a plane with speed 2 times faster than the speed of sound. If you wish same, then our dreams will soon come to a reality. Supersonic commercial aircraft could soon take to air again, as NASA recently announced the successful completion of critical ground tests of its experimental X-59 Quiet Supersonic Technology aircraft, Quest. Lockheed Martin was awarded the contract to develop a quiet supersonic plane in 2016 and has been working on the plane since 2018. The world's first supersonic commercial aircraft, the Concorde, flew for the first time in 1976, which was at the time certainly a revolutionary event, but the aircraft's lifespan lasted only till 2003. One of the major problems with Concorde was the shockwave that the aircraft sent into the air when it approached supersonic speed, which was so strong that it would shatter glass if it went over densely populated areas. These sonic booms can generate a huge amount of sound energy, approximately 110 decibels, which sounds like thunderclaps or explosions that can be heard from 30 miles, 48 kilometers, away, and extremely violent. This is why supersonic commercial flights are banned by the Federal Aviation Administration, FAA. So, the X-59 is NASA's answer to this problem that could transform aviation by enabling supersonic aircraft to accelerate to those incredibly high speeds right after takeoff. Supersonic commercial aircraft could soon take to air again, as NASA recently announced the successful completion of critical ground tests of its experimental X-59 Quiet Supersonic Technology aircraft. Ground tests on the X-59 were done to ensure the aircraft's ability to withstand the loads and stresses of supersonic flight or flight at speeds faster than Mach 1. The plane's fuel systems were also calibrated and tested at Lockheed Martin's facilities. With its return to California, the X-59 will undergo further ground tests as it approaches full completion of its development and continues to make progress on its way to first flight, NASA wrote. The aims of these tests were threefold. Firstly, the X-59 had to be tested if it could handle the pressure or stress on its structure, which would typically be maximum when the aircraft experiences rough air, makes quick turns, and during landing, among others, as described by NASA in its previous press release. The second objective was to calibrate the sensors built into the X-59 that are designed to tell the pilot how much stress is being measured at that point on the airplane. This was done by comparing what the sensors say with the known amount of stress being applied during a test. The third goal was to compare the data obtained from these tests with the computer models that were used in designing the airplane in the first place to check if the airplane is built as designed and whether the design is accurate. Being a purely experimental testbed, the X-59 makes heavy use of components from other Lockheed Martin aircraft, with only about 10% of the design being new, to help keep it as simple and low cost as possible. Its landing gear is from a USAF F-16 fighter, a cockpit canopy from a NASA T-38 trainer, a propulsion system part from a U-2 spy plane, and a control stick from an F-117 stealth fighter. It is powered by a single modified General Electric F-414 engine, other variants of which are found on Boeing's F/A-18EF Super Hornet fighters and EA-18G Growler electronic warfare jets, as well as the Saab Gripen fighter jet, among others. The length of the plane is 28.7 meters and its wingspan is 9 meters long. The front of the plane features a thin extended nose, 30 feet in length, and completely lacks forward visibility for the pilot. Instead, the X-59's pilot will employ a remote vision system known as the External Vision System, XVS, to see through feeds from an array of forward-facing high-resolution cameras. The extended nose and no forward visibility are meant to enable the aircraft's entire front end to be optimized for sonic boom mitigating supersonic flying. Reports suggest that the structural tests recently completed will be followed by independent measurements of a small-scale model of the X-59 by NASA and the Japanese Space Agency, JAXA, following which a target date will be set for the first flight, expected to occur later this year. Acoustic validation flights will be further conducted in 2023, followed by the planned community overflights between 2024 and 2026, which will involve flights over various U.S. cities to solicit public feedback. NASA plans to deliver the results of the community overflights to the International Civil Aviation Organization and Federal Aviation Administration in 2027, the space agency said in an early. With that information in hand, regulators will be able to decide if a change should be made in rules that prohibit supersonic flight over land, a decision that would be expected in 2028. What are you still waiting for? Subscribe now and enjoy the evolution in science. What are you still waiting for? Subscribe now to our channel, Science is Curiosity. Thanks for watching.